Welcome everyone to this session on how to tackle training assessment in VR with eye tracking. My name is Johan Boven. I am the director of XR software and ecosystem here at Tobii. And with me today, I have Dr. Sam Vine from University of Exeter and Cineon Training. We have a very interesting session here today with something as special as real deep scientific research that has made it all the way into practical applications and product offerings in the space of VR training and specifically for aviation. So without further ado, I want to hand it over to you, Sam.
Hello, everyone. My name's Dr. Sam Vine. I'm an associate professor of psychology at the University of Exeter, and I'm a director at Cineon Training. I have a research program with my colleagues at the university that's interested in human performance and learning. We are cognitive and neuropsychologists, and we apply our work to a range of safety-critical and high-performance industries. Eye tracking and VR technology are the primary tools you'll find in our laboratory. These help us to perform experiments and understand the way in which people think, feel, and behave in performance settings. Using these tools and in collaboration with our spin-out organization, Cineon Training, we've been able to develop new and innovative training products. I want to tell you today about one specific VR tool we've made for the aviation industry, which is due to be launched later this month. Like all innovation and scientific advancements, there were some clear motivations and driving forces behind this project. First, aviation is moving towards a training model of training and assessing 9 critical competencies set out by the International Civil Aviation Organization. Rather than focusing too heavily on traditional markers of skill, such as years of experience or flying hours, assessment of competency in technical and non-technical skills ensures that the pilots are efficient and effective at flying aircraft safely. But these competencies are hard to assess and train, particularly the non-technical ones, such as communication, decision-making, and situational awareness. And so a new approach is needed. Second, the global pandemic has generated a number of new challenges for aviation. Not only do we need to create pandemic-proof training for the future, but we also need to support what was an idle workforce to return to work safely. How do we know if pilots' flying competencies have been maintained? As such, there is a need for flexible, mobile, and automated training that enables the fast and effective assessment of aviation-specific competencies at scale. We call this project Training Aircrew Competency Using Eye Tracking, or TACET. We developed this with our aviation specialists at Aquila Jet Training. TACET involves the assessment of competency via eye trackers that are built into VR headsets displaying aviation simulations. We believe this to be an accurate, reliable, and covert way of meeting this challenge. Here you can see we've adopted the Neo Pico 3 with Tobii eye tracking, as we believe this provides the flexibility and the mobility that we need. TACET is not a traditional flight simulator, but rather an assessment and training tool that uses simulated aviation scenarios and new training techniques that we hope will help the aviation sector to overcome some of the challenges described previously. TACET was built from the ground up by our team of developers at Cineon. We built an Airbus jet simulation from scratch using LiDAR scanning of a real grounded aircraft. We programmed some basic avionic functions, such as flight controls and engine management systems, and we've integrated 3 innovative and novel training and education tools that we think are going to have a real impact in aviation. First, we've included a competency scoring system used by trainees in vivo during simulated flight scenarios. This system records behaviors, records inputs, and takes voice recordings to keep a library of information about what the trainee was doing, thinking, and feeling. Trainees can map their behaviors to competencies, and the trainers can then see where there is a need for improvement. Second, we have an automated and intelligent competency assessment system that uses the eye tracking built into the headset to understand how well the trainee is performing. The integrated eye tracking technology and some clever mathematical algorithms enable the software to monitor the pilot's visual behaviors and generate a competency score that can be fed back to the instructors and trainers. This approach is automated and covert and means, therefore, that the assessment is ongoing throughout the aviation simulation. Finally, and perhaps most importantly, we are able to fully recreate the training scenario in the back end of the software, offline or remotely, for additional training and education. This recreation includes all of the bodily behaviors and eye movements of the trainee, which will enable reflection, coaching, and additional learning to take place. Here, the trainer and the trainee can replay the competency assessments. They can explore the competency assessments derived from automatic eye tracking, and they can replay the scenario from multiple angles as many times as is necessary. The eye tracking footage gives the trainer another layer of detail to explore, providing an insight into the cognition and the decision-making of the trainee. The coaching sessions that can subsequently happen between a trainer and a trainee can be held online or remotely, with no need for the training instructor to be geographically located with the trainee. For example, what you can see and hear here is a Zoom-based feedback training session following on from the trainee's session within the TACET system in their home, having received the headset through the post. How do we know this system works? Well, we've been through several stages of testing the efficacy of this approach. We've performed initial alpha and beta testing of early versions of the software, and we've recently connected with a UK aviation training provider, L3Harris, to be able to access qualified pilots and test them on the system at Gatwick Airport in London. First, we simply ask questions regarding the basic validity of the tool. We ask pilots what they think, and here you can see responses to simple questions such as how convincing they found the virtual environment, how useful they thought the training was as a training device. While we have a healthy range of responses here, the average response was positive and in keeping with other successful simulation tools that we've built in other industries. TACET calculates competency using the eye tracking footage only. And with these data, we were able to look for distinctions between skilled and non-skilled pilots. In fact, we were able to look at distinctions between trainees who have experience of flying and those trainees who are still learning the ropes before commanding an aircraft. Using eye tracking footage and calculating the pattern of the different eye movements, we've shown that the assessment of competency discriminates between those with experience of flying and those without. And this was across two separate aviation scenarios that you can see here: a rejected takeoff and what's called a blue reservoir fault of the engine. As well as distinct differences between groups of pilots, we've also shown correlations between our eye tracking metrics of competency and traditional measures of expertise. For example, here measured by the number of hours that pilots have been in command of an aircraft. Our new measures of competency, measured by eye tracking alone, are correlating with the existing assessments of seniority and experience that are used in the aviation industry. Taken together, these data give us confidence that the system is effective and can be added to the arsenal of tools that flight instructors currently use to train pilots. In summary, we have good evidence that there is initial validity of this system. Our next step is to consider ways in which we can take this product to end users. Although not entirely defined, our likely route to market is via the sale of licenses of the TACET software, which will be boxed with a Pico Neo 3 headset. These packages will be picked up by approved training organizations or commercial airlines who deliver their own in-house training. Given the novelty of the situation that aviation faces, we also believe that new applications of this training will emerge as the industry recovers from the pandemic and other associated stresses and strains. Finally, we are looking at ways in which we can redevelop and repurpose this software for other applications where competency assessment is also required. For example, in the operation of heavy machinery or complex systems in the gas, oil, and nuclear sectors. To find out more about TACET, you can follow the link on the screen. Thank you very much.
Thanks for that great presentation, Sam. It's amazing to see how real research actually makes it all the way through to commercial products. And I really noticed that the scientist in me gets all giddy when I get to see regression graphs and looking at correlations between the metrics you have and actual pilot experience. Really good to see how actual applications can use this kind of solid science. I wanted to take a few minutes here as well to look at the technology that Tobii brings into XR with eye tracking. And first of all, talk a little bit about what eye tracking is. So in the premium headsets that you have on the market today and find Tobii's eye tracking integrated, there are a couple of components that are built into the headsets. There's illumination and image sensors that capture a view of parts of the user's face, and a substantial algorithm package running on the headsets that measure where the user is looking. This technology is used for a number of different applications, and we'll go into detail, but it sort of amounts to making the devices better and allowing them to household system resources in a better way. It's about making the user experience better, more immersive and more natural in various user experiences. And finally, and most importantly for applications such as Senior trainings and what Sam talked about, actionable insights is a key thing that eye tracking delivers, both in terms of where user attention is directed, but also on a higher level with detecting things such as expertise, cognitive load, stress, and fatigue. From Tobii's side, we see this technology being picked up in a large number of application areas. We see it in healthcare, where we have diagnostical assessment tools and even therapies leveraging eye tracking in VR. It is used a lot in behavioral research and in a non-invasive way, very much like Sam was describing that he and his research team is doing. On the more commercial side, we also see eye tracking being picked up in various types of product design and focus groups, either for large spaces such as retail rooms, but also in the more in smaller appliances and product packaging design. Around the corner, we know that eye tracking is being looked at for various social applications, making social avatars more natural and more immersive experiences when you meet others in shared spaces. And finally, we know that gaming is going to be a big driver of VR in the future as well. And based on our experience in the PC side, eye tracking has a lot of ways of enhancing user interactions in the gaming area. More specifically, in terms of the technologies that Tobii bring to the XR space and what those technologies solve in terms of problems that we all find in one way or another in VR. First of all, we have Tobii Spotlight technology. That is our advanced eye tracking that is optimized specifically for foveation. So foveation is the technology of concentrating graphical resources to the area where the user is looking. We only have high resolution on a very, very small area of our retina. So when our eyes dart around, the only part that really needs to be high resolution and really crisp is where we're looking. And with the help of Tobii Spotlight system, a headset and a GPU can know exactly where those resources need to be directed. Secondly, automatic IPD is a key problem to solve for where eye tracking has its part. In order to make a natural and really immersive graphical experience, both the 3D world and the actual headsets need to be adjusted for the distance between the user's eyes. So eye tracking provides a critical component in that technology stack. A third area where we see a lot of use for eye tracking already today is when it comes to advanced user interfaces. Controllers with laser pointers have its varying limitations, and adding eye tracking to those paradigms is a game changer. Instead of pointing a shaky laser to various buttons, you can just let your users now look at objects, have them highlight, and click with a controller or a hand gesture, or even just by waiting for a second. And then last but not least, anywhere where we have objects in a 3D environment and start to use eye tracking to manipulate them, the knowledge of where attention is directed and not only where the eyes are pointing from a millisecond to millisecond is a huge thing. So Tobii has developed an object attention engine called Tobii Focus that brings a whole new level to interaction as well. And last but not least, this is the lineup of headsets available on the market today where eye tracking is integrated. These headsets all have Tobii eye tracking, and for anybody who is looking at exploring these technologies, I would highly recommend getting one of these. Pico's Neo 3 Pro Eye just came out very recently. So I want to make a shout out to Pico and their great team who have been working with Tobii for many years to bring this great product available to everyone. And with that, Sam and I would like to thank you so much for your attention here today. We are excited about training in VR and aviation and hope to have great discussions with you all in a not too far distant future. Thanks for today.